Hi, in our last video we started our edit proposal function, and in this video we are going to have two more functions to create, and then I promise we are going to move on with our candid file. Now here I'm going to create a new one. We are going to say ICCDK update as we used to, and this function is going to be really similar to the previous one. So I'm going to copy this function here, or let's copy like this and paste it here. Instead of edit proposal, we are going to call it endProposal, and we only need the key. And also we don't need this process too. The beginning of the function is going to be the same. Instead of old proposal, let's call this just proposal. Again, we are doing the same thing. We are retrieving the proposal, but there's a chance that we may not retrieve it. So for this situation, we have a match here. And in this match, we are checking if we were able to get this proposal option here. And if we have some value, then we are going to say our proposal equals to value. But if we got none, then we are going to return no such proposal error. Then we are checking if the owner of the proposal is the one who is calling this function. And if not, we are going to return the access rejected error. Now that we did our checks, we can update our proposal. For this, we are going to say proposal.isActive equals false. It's going to give us an error. Now, of course, we also need to say this proposal.owner, and we are going to update this value in a bit. Okay, now that we made our checks, we are going to say proposal.isActive. And since we are altering the proposal field here, we are going to say let's mute our proposal needs to be mutable so that we can update it here. And we are going to say false. This way we got our proposal and we changed its isActive field to false. That's how we are going to end our proposal. And then we are going to insert this new proposal with the isActive field converted to false. And instead of a value here, I'm going to say proposal. And we are going to have a result, which is also an option. So we can have a value in the sum like this. So if that's the case, we don't care what value we have. It means that it was successful. Then we are returning okay. If not, if we got a none, then we are going to return an error saying update error. And this will be our endProposal function, which is again very similar to the one we created above. Above, we actually created a proposal and we updated two parts of this proposal and we converted the old ones to the new ones, and here we just changed its isActive field to false. Now we are going to create our last function, which is also going to be an update function, and we are going to call this function both. We are going to have key as the parameter like before, and here we are also going to have a choice. This is a function that we make a choice. All right. Then this is going to return a result, and this result is going to be either okay or we are going to return an error, which is a vote error. And in this function, we are going to start with the proposal map.width, and we are going to have our p and our curly brackets. All right. In this function, what we are going to do again is very similar in the beginning. So we are going to say let proposal option equals p dot borrow dot get, and we are going to pass the key here, and this is going to return us an option. So we are going to open up this option like we did in the previous functions. So let's say let's mute proposal, which is going to be a proposal, and here we are going to say match proposal option. If we have some value, then we will say our proposal is equal to the value. If we got none, then we are going to return our error, which is the vote error, no such proposal. Now that we checked if we got the right proposal, now we can work with it. We are going to get our color here. I'm going to say ICCDK color, so we can use later. And next we are going to check if the address that is calling this function has voted for our proposal before. For this, let's say if proposal dot voted dot contains, and this method returns true if the given parameter is in the vector and returns false if not. Let's say color here, and if this is the case, we are going to say return error, and we are going to return vote error, and this will be already voted. And then we are going to say as if that's not the case, but the proposal that is active equals false, then we are also going to return an error, and we are going to say proposal is not active. I think it's a pretty self-explaining error. Okay, now we check two situations. If the address that called this function is in the voted vector that we had in our proposal, and also we checked if our proposal is active. If the caller of this function can pass these checks, then we are going to move forward with the voting process. For that, I'm going to say met choice, and if we have choice approve, then we are going to say proposal dot approve plus equals 1. So if the choice is approved, then we are going to increment approve. If the choice is reject, we are going to increment reject, and same for the pass. And we are checking this by using choice approve, which we got as a parameter here. So the type of this choice, if you remember that we created this last lesson, we had 3 types in this choice. The first one was approve, second reject, and the third one was a pass. And that's how we are actually getting our input by choosing from one of each option. And we are going to do similar things for the rest. Let's say reject for this one and reject for that one, and finally we have pass here and we have pass here. Now we are going to say proposal dot voted dot push, and we are going to push our caller here. So if they were able to vote with match, then we are going to add this principal to our voted vector. So the next time when they try to vote again, we are going to catch them here where we said if proposal.voted.contains caller. If we didn't have them in the first place after they voted with this line, we are actually adding them to our vector so that the same person cannot vote again. And after this, we are going to say that result equals p dot borrow mute dot insert, and we are going to insert our key and value. And after this, we are going to check if we got none or some result, and this is going to be the same as the one before. We are going to say some, and if that's the case, we are going to return okay. But if this is not the case, then we are going to return an error, and the type of our error will be vote error, and we are going to say update error because we don't know what went wrong, but we just couldn't update the state. And now this will be all of our contract. So let's see what we did here, and instead of value, sorry, we should say proposal. Okay, now we are okay. Again, let's check what we did today. First, created a function called endProposal, and this was very similar to the one before, but what we did is we got the proposal and we checked if we were able to get the proposal, and then we checked if the caller of this function is the owner of the proposal. If not, then we return the access rejected error. But if they passed our checks, then we said that we are going to make this proposal inactive, so we made is active false, and then we updated our proposal in our stable B3. Then we checked if we were able to, if we actually did update our state, our data on the chain. And if we didn't have any problem, we returned okay. And if we had some problem, we returned update error. So with the vote function, we did the first check as we did before. We got the proposal and we checked if we actually got the proposal or we got none. If we got the proposal, then we got the caller here so that we can use later. And we checked if the address has already voted. If they voted, they would be in our voted vector in this proposal. So we checked that here. And then we check if the proposal is active because they cannot vote on an inactive proposal. And if this is the case, then we said proposal is not active. And then we had our match statement. And in this match statement, we looked for 3 possible cases. In the first case, if we got the approve, we incremented approve. And if we got the reject, we increment reject. And the same thing for the pass. And then after this voting process, we added the caller of this function to our voted vector so that they cannot vote again. And finally, we inserted this new version to our stable v3. Then we check if we actually were able to do what we intended with this line here. And if we have some error, we return it. If not, we return OK. So as you can see in our functions, we have similar structures. What we do is we get the proposal, we check if there was an error, and we check additionally if needed, like if the caller is the owner or if the caller has voted. After these checks, we update the data and we insert back the data to the same place, and we check that if we were able to insert this. So even though we have some differences, the whole idea is the same in general. And this concludes our smart contract. So again, these were our functions and we had our state in the beginning. We are also going to delete this invalid choices because we have 2 different choices here and we are checking with 3 possible choices. If our choice is not one of them, then it cannot be not one of them since we are using an enum and there is only 3 possible variants. That's why we are using enum. In our next video, we are going to create a candid file for the smart contract because we know how this contract works and you know how this contract works. The computer knows how this contract works, but the problem is our front end still does not know how this contract works. And with this candid file, we are going to fix that error. So thank you very much for sticking with me the whole process while we develop this smart contract. And in the next video, we are going to conclude our smart contract with candid file. So thanks again and see you on the next one.